we have talked about part A questions from the paper quantum mechanics, especially from the relativistic quantum mechanics. The first question is, what are Polyspin matrices? Sigma x, sigma y and sigma z are called Polyspin matrices. They are 2 by 2 in dimension. The values are given below. If you take the square of sigma, that sigma square is equal to sigma x square plus sigma y square plus sigma z square, whose value is 3. Actually, sigma square is nothing but sigma dot sigma. Sigma dot sigma is this much, because sigma is I into sigma x plus j into sigma y plus k into sigma z. Sigma dot sigma is sigma square. The second question is, prove that sigma dot a into sigma dot b is equal to a dot b plus I sigma dot a cross b. Here, the vector a equal to I into x plus j into ay plus k into az. Vector b equal to I into bx plus j into by plus k into bz. Sigma equal to I into sigma x plus j into sigma y plus k into sigma z. If you take the dot product of these two, sigma and a, this is the result. In the same manner, the value of sigma dot b is this much, sigma x bx plus sigma y by plus sigma z bz. So instead of sigma dot a and sigma dot b, we have substituted these values. Make your multiplication, we can get the equation of this form. Here sigma x square equal to sigma y square equal to sigma z square is equal to 1. Then take out the sigma x sigma y outside, sigma x sigma y, then align the terms ax by, then another one term is present with sigma y sigma x. Actually sigma x sigma y equal to minus sigma y sigma x, because these two are anti-commuting in nature. Already we have taken out sigma x sigma y outside, so here a negative sign is present. Sigma x sigma y, if you combine these two terms by the way of taking sigma x sigma y outside, this is written as ax by minus ay bx, because sigma x sigma y equal to minus of sigma y sigma x, because sigma x and sigma x are anti-commuting in nature. So in this way we have developed this equation. See this sigma x sigma y into this much. Here sigma x sigma z, I have aligned ax bz, then minus az bx, because sigma x sigma z is equal to minus sigma z sigma x, which means that sigma x sigma z plus sigma z sigma x equal to 0. So this is the second term. Then third, sigma y sigma z. Say sigma y sigma z, take this term outside. So remaining terms are ay bz minus az by. Here ax bx plus ay by plus az bz is our a dot b. This is the proof. This is our a dot b. Then the value of sigma x sigma y is I sigma z. Sigma x into sigma y is I sigma z. So instead of sigma x sigma y, we have to write I sigma z. Then sigma x sigma z. See here, x should be followed by y, but here the term z is present. So sigma x sigma z is minus I sigma y. Then sigma y sigma z is plus I sigma x. Just instead of sigma x sigma y, sigma x sigma z and sigma y sigma z, we have substituted the values. The proof is available here. Then in order to change this negative sign into positive, interchange the terms. This ax bz minus az bx is changed as az bx minus ax bz. Here the minus is changed as plus. Here a dot b is written as such. Take this I outside. Then the rest of the terms, sigma x into this quantity plus sigma y into this quantity plus sigma z into this quantity is sigma dot a cross b. This is the value of sigma dot a cross b. Therefore, the value of sigma dot a into sigma dot b equal to a dot b plus I sigma dot a cross b. Just we have proved. The third question is, what are the properties of Polyspin matrices? Polyspin matrices are 2 by 2 in dimension. They are all Hermitian. Their square values are unity. Their eigenvalues are plus 1 and minus 1. They are anti-commuting in nature. That means sigma x sigma y equal to minus sigma y sigma x. Therefore sigma x sigma y plus sigma y sigma x equal to 0. And what are Dirac matrices? The matrices alpha x, alpha y, alpha z and beta are called Dirac matrices. These Dirac matrices are derived from Polyspin matrices. Polyspin matrices are 2 by 2 in nature, but Dirac matrices are 4 by 4 in nature. See, this is our sigma x, this is our sigma x. So 0 sigma x 0. This is our alpha y. This is 0, this is sigma y, this is sigma y, this is 0. So that we may expand 2 by 2 into 4 by 4. This is the value of alpha z. Alpha z is expressed in terms of 0 sigma z 0. Then beta is I 0, 0 minus I. These are all called Dirac matrices. What is meant by trace of a matrix? The sum of the diagonal elements is called the trace of the matrix. Say this is a beta matrix. If you take the sum of the diagonal elements, this is called diagonal element. Don't consider this one. This is the diagonal element here. If you take the sum of these elements, that is called trace. Here the trace value is 0. The trace values of Dirac matrices are 0. If you go for alpha x, this is a diagonal element. If you take the diagonal element, all are 0. In the case of alpha y, this is the diagonal element. These are all the diagonal elements. If you take the sum, the value is 0. In the case of alpha x, these are all the diagonal elements. If you take the sum, the value is 0. So trace means sum of the diagonal elements. Why do Dirac matrices have even dimension? The trace values of Dirac matrices are 0. That means the diagonal element sum value is 0. This is possible only when the number of plus 1 eigenvalues equals the number of minus 1 eigenvalues. This restricts the dimensions of Dirac matrices to even. See this beta matrix here, 2 plus 1 eigenvalues and 2 minus 1 eigenvalues are present, then only the sum is 0. We know that the trace of alphas and beta trace values are 0, therefore the number of plus 1 eigenvalues should be equal to the number of minus 1 eigenvalues. The smallest possible even dimension is 2 by 2, but here we are using 4 operators, alpha x, alpha y, alpha z and beta. Therefore the Dirac matrices are 4 by 4 in nature, that is even in dimension. What are the properties of Dirac matrices? Dirac matrices are 4 by 4 in dimension, it is even dimension. Then trace values are 0, then squares are unity, they are anti-commuting in nature, they are all Hermitian. If you take the conjugate and transpose, we can get the original matrix. Therefore we can call this one as a Hermitian. All the Dirac matrices are Hermitian in nature. Their eigenvalues are plus 1 and minus 1. Write on the Dirac's free particle Hamiltonian. H equal to C alpha dot P plus beta MC square is the Dirac's free particle Hamiltonian. If it is not free particle, we have to add potential energy term. H equal to C alpha dot P plus beta MC plus V of R. If it is a free particle, a constant force is acting or no force is acting. Therefore, H equal to C alpha dot P plus beta MC square. Here alphas and betas are 4 by 4 matrices. Write on the Dirac's equation for a free particle. Just replace H by means of E, then the energy operator is IH cross dou by dou T, then the momentum operator P equal to minus IH cross delta. Then instead of H, we have to put E, because H is equal to E, so H equal to E, then the energy operator is IH cross dou by dou T. Allow this operator to operate on the function psi. Then instead of P, we have to put minus IH cross delta, so minus IH cross C alpha dot del, that should be multiplied by psi. The operator is allowed to operate on the function psi plus beta MC square into psi. This is called Dirac's equation for a free particle. What are Dirac's spinors? Since alphas and betas are 4 by 4 in dimension, the wave function psi must be a column matrix with 4 elements. This is a column matrix with 4 elements, because in matrix multiplication, alpha is 4 by 4. Here, alphas and betas are multiplied by the wave function psi. In matrix multiplication, in order to multiply a matrix with another one matrix, suppose the first matrix is 4 by 4 in dimension, so the second matrix, that is multiplication matrix, should start with 4 rows at least. Therefore, psi is a column vector with 4 elements. Here, row 1, row 2, row 3, row 4. 4 rows are present, but only one column is available here. Then the psi dagger conjugate transpose is psi 1 star, psi 2 star, psi 3 star, psi 4 star. Conjugate transpose is called dagger. These wave functions do not transform as 4 vectors. They are referred to as Dirac spinors. What is a hole? The antiparticle of an electron is called a hole. The charge of a hole is modulus of E. Write down Klein-Gordon Hamiltonian. H square is equal to E square equal to C square P square plus M square C power 4 is the Klein-Gordon Hamiltonian. Here M is the rest mass. So this is the way of arriving Hamiltonian. Don't bug up this. From the formula variation of mass velocity we arrived this relation. Write down Kg equation. Just replace H with the help of E. H psi equal to E psi. So H is replaced by the operator E I H cross dou by dou t whole square. Then that is multiplied by psi. C square into, instead of P we have to put minus I H cross del square psi plus M square C power 4. If you make our simplification, we can get this equation. This is our D'Alembert operator. So D'Alembert operator operating on the other function psi is equal to M square C square by H cross square into psi. This is our Kg equation in one form. What are the drawbacks of Kg equation? Kg equation is used to describe spin zero particle. It doesn't say anything about the spin of a particle. This equation does not explain the concept of negative energy. These are the drawbacks of our Kg equation. Write down the planar solution to the Kg equation. Psi of r comma t equal to e power I into k dot r minus omega t is the planar solution. This is an eigenfunction for the energy and momentum operators with eigenvalues h cross omega and h cross k respectively. So this is the way of arriving these energy eigenvalues. Write down the planar solution to Dirac's equation. Psi j of r comma t equal to uj and t power I kr minus omega t is the planar solution for Dirac's equation. Here the value of j equal to 1, 2, 3 and 4 because psi should be a column matrix with the 4 elements. Since alphas and beta are 4 by 4 in nature. Then psi j is an eigenfunction for energy and momentum operators with the eigenvalues h cross omega and h cross k respectively. Write down the normalization condition in Dirac space. Usually the normalization condition in the non-relativistic case is psi star psi d tau equal to 1. In the case of Dirac equation, the normalization condition is psi dagger psi d tau equal to 1. Then the expectation value of an operator A is, first we have to put the complex conjugate of the function and the operator value and the wave function psi into d tau. This is possible in non-relativistic case. But in Dirac's field, relativistic case, the expectation value of an operator is psi dagger, then A, the operator, psi into d tau. This is called expectation value or most probable value. Give the drawbacks of non-relativistic Schrodinger equation. Kg equation is called as relativistic Schrodinger equation. Ordinary Schrodinger equation is called a non-relativistic Schrodinger equation. In the non-relativistic Schrodinger equation, the position coordinates are expressed in the second order, whereas time is described in the first order. This violates the space-time symmetry requirement of spiral theory of relativity. See this h psi equal to e psi. This is Hamiltonian operator. This is energy operator. In the Hamiltonian operator, del square position coordinates are expressed in second order. These are all called space coordinates. But time, first order differentiation, is expressed in first order. This violates the space-time symmetry requirement of the spiral theory of relativity. We have to express both the coordinates either in second order or in the first order. With the help of Kg equation, we have expressed all the quantities in second order. But in the case of Dirac equation, we have expressed both space and time coordinates in terms of first order. What are negative energy states? Dirac energy spectrum has two branches. One starts with plus mc square and ends with plus infinity, and another branch starts with minus mc square and ends with minus infinity. The two branches are separated by a forbidden gap of width 2 mc square, in which no energy level can exist. This is called as negative energy state. See that what is meant by pair creation? When the light of energy greater than the width of the forbidden gap is incident on the negative energy state, see here, the electron in the negative energy C will make a quantum jump to the positive energy state. Here the electron is making a positive quantum transition to the positive energy state and thereby leaving a hole in the negative energy C. The process of creating a hole and a solid electron using a photon is called pair creation. Suppose if you give a photon of energy greater than this width, an electron in the negative energy C may be jumped to the positive energy state and thereby leaving a hole in the negative energy C. Creation of hole means removal of certain amount of negative energy and charge that must be equivalent to creation of the same amount of positive energy and charge. So the process of creation of a hole and a solid electron using a photon is called pair creation. Suppose the solid electron meets the hole, the energy is coming out of the system, that is called as pair annihilation. What is spin value of a Dirac particle? The spin value of an electron does not carry any energy, therefore it can be obtained from the coupling of orbital and spin angular momenta. You know that the x component of orbital angular momentum is Lx. The x component of orbital angular momentum does not commute with the Hamiltonian of Dirac. If you add some quantity, you may get our total angular momentum, that is conserved. Say the d by dt of Lx plus half h cross sigma x equal to 0. So the quantity Lx plus half h cross sigma x equal to constant. In a system, the total angular momentum is conserved, so the added quantity should be spin angular momentum. So the value of spin is half h cross sigma. You know that Jx equal to Lx plus Sx equal to constant. So the quantity half h cross sigma is our x component of spin. In general, the spin S is half h cross sigma. Here plus half h cross and minus half h cross are the eigenvalues. What's the value of magnetic moment of an electron? Suppose an electron is orbiting around the nucleus, yes, current is produced. The magnetic moment is the product of the current and the area of the orbit. The magnetic moment is usually expressed in terms of the Bohr magneton. One Bohr magneton is EH cross by 2m. Here the magnetic moment of the electron mu equal to EH cross by 2mc into sigma.